Hello everybody, this is Mr. Nardelli. I'm going to be talking to you about multiplying polynomials. There are three basic types. First off, if we have a monomial times a polynomial. This is the distributive property, but we have a couple of x squareds and maybe even some y squareds and different variables involved in here. So when we multiply this, we start with 5 times 4, which is 20. I'm going to go ahead and show my answer. And then we do, let me erase that little thing. We have 5 times 4, which is 20. And then we have x squared times x to the third. Remember, you have to add the exponents, so we get x to the fifth. Then we distribute the 5x squared times the 5. So that would be 5 times 5 is 25. And then x squared times no x's in there just gives me x squared. So when I multiplied the monomial times a polynomial, I end up getting 25 x to the fifth, 20 x to the fifth plus 25 x squared. Okay, our next one is when we have a binomial times a binomial. This is the FOIL method, which if you remember is first, outer, inner, last. So what we're going to do is multiply every number times every number. We'll start with the first numbers, which are x squared and x squared, x and x. So x times x gives me x squared. Then I do my outer numbers. My outer numbers are x and minus 8. It's not highlighting, there we go. So x times minus 8 gives me minus 8x. Now we do our inner terms, which are 6 times x, giving me 6x. And then our last terms, which typically are just the numbers, we have plus 6 times minus 8, giving me a minus 48. Then I'm going to combine my like terms, which most of the time will be these two middle terms. I have minus 8 plus 6. So that's in essence 8 minus 6, but giving me a negative. So I end up getting x squared minus 2x minus 48. And that is considered what's called a trinomial, 3 terms, and that would be my answer. Now the kind of tough ones to keep track of are when you have a binomial times a trinomial or even times a larger number. For example, if I were to have 4 or 5 terms in here, you kind of have to really keep track of this. So we start off with this 5x squared, and we're multiplying it by everything in here. So I'm going to go ahead and put that first line right there. So I've got 5 times 4 giving me my 20, and then my x squared times x to the third, that's 2 plus 3 giving me 5, so it's 20x to the fifth. My next one I'll do 5 times 5 giving me 25, and then x squared times x squared, that's 2 plus 2 is 4, giving me x to the fourth. So my second term is plus 25x to the fourth. My last one will be 5 times minus 8, giving me minus 40, and then x squared times, there's no variable there, so I've got x squared. Okay, now I'm going to jump to this 8. Now, what I like to do is stack them, and I'll show you why in just a minute. So I've got 8 times 4 giving me 32, and no variable times x to the third gives me x to the third. I purposely put it over here because it didn't match up with any x to the thirds on the top. There were none, so I put it by itself. Now I'll do 8 times 5 giving me 40, and no variable times x squared gives me x squared. Now I'm purposely putting it underneath the top x squared because then I can visually see I'm going to combine them. My last term is 8 times negative 8, giving me negative 64, and that sits by itself. Now, if I look at this, I'm basically going to add these. I guess I'll put a addition symbol in there. And 20x to the fifth is not added to anything, so it just comes down. 25x to the fourth is not added to anything, so it comes down. But here, look what I have. I have minus 40x to the second plus 40x to the second. In this example, these two basically cancel out and I get 0. If I wrote 0, it would be correct, but I'm just not going to write it. Now this 32x to the third doesn't compile with anything, so I just bring it on down, and the same with the minus 64. So my answer would be 20x to the fifth plus 25x to the fourth plus 32x to the third minus 64. If you need anything, email me at nardelli.efsc@gmail.com. Thanks.